All right, we want to solve this system of equations using matrices. We're going to use Gaussian elimination with back substitution or Gauss-Jordan elimination. So I'm going to use Gauss-Jordan elimination where I get the row reduced echelon form or the reduced echelon form. I'm going to put the coefficients in row 1 for the first equation. I'm going to put the coefficients in row 2 for the second equation. And notice in row 1 are all the in column 1 are all the coefficients of W. In column 2 are the coefficients of X. In column 3 are the coefficients of Y. And in column 4 are the coefficients of Z. And in column 5 are the constants on the right side of the equation. All right, so the vertical line separates the coefficients of the variables from the constants. So the vertical line goes in the place of the equals. We will form the augmented matrix which corresponds to the system of equations, and that's what we've just done below. So we want ones on the diagonal left of the vertical line and zeros on all the non-diagonal entries left of the vertical line. If possible. Sometimes it's not possible to obtain this form. Elements on the diagonal are in the same row as column. The diagonal entries are 1, that's the one we find in row 1, column 1. Another one, which we find in row 2, column 2. So see how the position or the value of the row is the same as the value of the column when we're on the diagonal. And that should be a -1, not a -y, that entry in row 3, column 3. So that -1 is my third diagonal element, and I have a 3 in row 4, column 4. That's also a diagonal element. So we're going to get the process is to first obtain the 0 elements that we desire by performing row operations. So first we're going to obtain the 0 elements in column 1, and we're going to do that by performing row operations. Then obtain the 0 elements that we desire in column 2 by performing row operations. Then obtain the 0 elements we desire in column 3 by performing row operations. And finally, obtain the 0 elements we desire in column 4 by performing row operations. So if we do this by obtaining the zeros first, we avoid fractions in our work, and then finally we will obtain the diagonal values of 1 that we desire. So what I'm going to do is I'm going to circle, as I'm working on a column, I'm going to circle the components that I want to change to 0. So I'm in column 1, I want this 2, this 1, and this 3 to become zeros. So I'm going to circle those. And I'm going to abbreviate the row operations that I'm going to perform. So I'm not going to change column 1, row 1. I'm not going to change row 1 at all in this process. I'm going to use row 1 to change rows 2, 3, and 4. So I'm going to multiply -2 times row 1 and add that to row 2. I'm going to move that down a little bit. Negative 2 times row 1 is going to get added to row 2. And that's going to give me, replace that 2 with a 0. Then I'm going to multiply negative 1 times row 1 and add that to row 3 to get my new row 3. Then I'm going to multiply negative 3 times row 1 and add that to row 4 to get my new row 4. So I'm going to copy row 1 because I'm not going to change that row. And now I'm going to follow the process. And multiplying every entry in row 1 by negative 2 and adding that to row 2 gives me 0, negative 1, negative 4, negative 3, and negative 8 as my new row 2. Now I'm going to multiply every element in row 1 by negative 1 and add that to the old row 3 to get my new row 3. That gives me 0, negative 3, negative 2, negative 3, and negative 6 as my new row 3. Now I'm going to multiply every element in row 1 by negative 3 and add that to row 4. And that gives me 0, negative 1, negative 2, 0, and negative 8 as my new row 4. And you may want to pause the video to check that that is indeed what I would get in those entries. Alright, now I'm going to get my zeros in column 2, so I'm not going to change row 2. So I recopy row 2, and it's going to be my anchor row. That's the row that's not going to change, and I'm going to get zeros in column 2 in rows 1, 3, and 4. So notice when I'm getting the zeros in column 2, I don't change row 2. So if I add row 1 and row 2, that'll give me the 0 I desire in row 1 that's in column 2. If I multiply negative 3 times row 2 and add that to row 3, I'm going to write these, make these a little smaller. And it's row 1 that I'm changing when I add row 2 to row 1. And I'm going to put what I'm doing to the anchor row first. So negative 3 is multiplied by row 2 and added to row 3 to get my new row 3. Negative 1 times R2 plus row 4 gives me my new row 4. So when I add row 1 and row 2 to get my new row 1, I get 1, 0, negative 3, negative 2, negative 4. Pause the video and check to make sure that's correct and that you understand where those values are coming from. Remember, I'm just adding the entry in row 1 to the entry in row 2 to obtain that new row 1. Now I'm going to multiply the entries in row 2 by negative 3 and add those to the old row 3 to get this new row 3 of 0, 0, 10, 6, 18. Pause the video and check to make sure you understand where those values came from. Now I'm going to multiply row 2 by negative 1 and add that to row 4 to get my new row 4 of 0, 0, 2, 3, 0. So I'm going to work with this matrix to get my zeros in column 3. So I'm going to change column 3, row 1, row 2, and row 4. I'm not going to change row 3 at all. So I'm going to rewrite row 3 from the previous matrix into this new matrix. That's the only row that's not going to change. The other 3 rows are going to all change. So I am going to multiply 10 times row 1 and add that to row 3 times row 3. 5 times row 2 will be added to 2 times row 3. And then row 3 minus 5 times row 3, row 4, R3 minus row 3 minus 5 times row R4 will give me my new row 4. Alright, so when I multiply 3 times R3 and add that to 10 times R1, my new row 1 becomes 10, 0, 0, negative 2, 14. Alright, and you may want to pause the video to make sure you understand exactly how those values are achieved. Everything in row 3 was multiplied by 3 and added to 10 times everything in row 1. Now let's multiply 2 times row 3 and add that to 5 times row 2 to get my new row 2 of 0, negative 5, 0, negative 3, negative 4. So 2 times everything in row 3 is added to 5 times every component in row 2. And so my new row 2 is 0, negative 5, 0, negative 3, negative 4. Now let's do row 3 minus 5 times row 4. And we get the new row 4 of 0, 0, 0, negative 9, 18. So that's my new matrix. And what I'm going to do, I only am doing this because it's going to make my work easier. And I'm not going to change row 1, 2, and 3 in what I'm getting ready to do right now. So I'm recopying those. And what I'm going to do to make my work easier is to multiply negative 1/9 times row 4. That gives me a 1 in that row 4, column 4 position. And I only do that because it doesn't cause me to get a fraction in the row 4, column 5 position. Now I want to get my zeros in column 4 in rows 1, 2, and 3. So I'm going to do 2 times row 4 plus row 1. Row 4 is my anchor row now. 3 times row 4 plus row 2 to get my new row 2. Negative 6 times row 4 plus row 3 to get my new row 3. So whatever my anchor row is, notice that I use that to change every other row along with the row I'm changing. So 2 times row 4 plus row 1 gives me a new row 1 of 10, 0, 0, 0, 10. 3 times row 4 plus row 2 gives me 0, negative 5, 0, 0, negative 10. And negative 6 times row 4 plus row 3 gives me 0, 0, 10, 0, and 30. And so you can check this, pause the video and check that you understand where those values are coming from. So now that I have all the zeros I desire, I'm going to get the ones by multiplying row 1 by 1/10, row 2 by negative 1/5, and row 3 by 1/10. I get a new row 1 of 1, 0, 0, 1, new row 2 of 0, 1, 0, 0, 2, a new row 3 of 0, 0, 1, 0, 3, and a new row 4 of 0, 0, 1, negative 2. And so now this is the reduced echelon form, row echelon form of the matrix. This matrix is equivalent to the original matrix and tells me that W is 1, X is 2, Y is 3, and Z is negative 2. So the solution set is the set containing the ordered 4 tuple 1, 2, 3, negative 2.